Hello my dear students. Today I will discuss about position vector. So position vector is very important in both vector analysis and classical mechanics. So how we define position vector of any particle or of any body? So to define the position vector of a particle or any body, in your class you have to consider that the particle or the body or a person is at a point. So its position should be a point. So we will use Cartesian coordinate system. We will do our calculations in 3-dimensional. So what do you mean by 3-dimension? Okay, 3-dimension means we have 3 coordinate. You have coordinate x, you have coordinate y, you have coordinate z, and this is the origin. So origin means 0, 0, 0. Now we can define this coordinate system as a reference frame. So this is a reference frame. So we will measure the position of any particle, or we will define the velocity and acceleration of any particle with respect to this origin and these 3 axes. So this is our reference system. So we can define this as S1. So now here we will assume that assume that S1 is at rest. That means this reference frame is not moving. So we can also take some reference frame which is moving. If we fix these 3 axes in a moving train, then the coordinate system will move with time. So in that case, the frame of reference or reference system okay I think reference only one. Okay, so in this case the frame of reference or reference system will be in motion. Now here we are only talking about the frame of reference which are at rest. So in this frame of reference we will just take a point P and we will define the point as x1, y1, z1. Now at this point P there can be any point mass or there can be any particle or any person. So how we will define the position vector of this person? So we will connect the origin and this point P and with a vector sign. So here OP vector is equal to position vector. So how we will write position vector? We write it as R. So for P point I will write it as R1. So what will be R1 vector? It will be simply the coordinate of P minus coordinate of O. That means x1 minus 0 to direction vector along x-axis plus y1 minus 0 into direction vector along z-axis plus z1 minus 0 along k-axis. This will be simply x1i plus y1j plus z1k. Now, if we consider this, the person at point P is changing our position with time. So, he is going along y direction. It's going along straight line motion. He has some straight line motion or she has some straight line motion, and after some time dt, a small time, his position will be q. And what are the coordinates? What is the coordinate? x2, y2, z2. So, similarly we can define the position vector. This is a straight line of this point. So, the position vector of this point q, what it will be? OQ. We can write OQ as R2, since this is point 2. Similarly, it will be x2i plus y2j plus z2 k. Now, P to Q, the particle moved, or the person moved from P to Q. It was his initial position, it is his final position. So, it is his initial position and it is his final position. Now, if he moves from P to Q in a very small time dt, as I have told, dt, then what will be his displacement? His displacement will be pq vector. So, displacement, as we define, the final position vector minus initial position vector. So, displacement it will be simply OQ minus OP. That means PQ vector. Now, OQ minus OP, what will be? x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k. So, simply, since it moves from P to Q in a very small time dt, now we can just define it as very small displacement. So, dx, dxi plus dyj plus dz k. Obviously, displacement is a vector like position vector pq. Since it is very small, here we are defining it at dr. So, dr is equal to dxi plus dyj plus dz k. Now, if it was not small, so if displacement was not small, then how we will write PQ? We will simply write is at R. R is equal to xi plus yj plus z. So, why we are taking small displacement? Because we want to define velocity. So, since, as we know, this displacement occurred in time dt. So, what is the displacement in unit time? So, displacement in unit time will be simply total divided by time. So, we can write is dy dt j plus dz dt k. Now rate of change of velocity is rate of change of velocity along x axis, along y axis and along z axis. So these are the three velocity components. How we are define this? Vxi plus vyj plus vzk. So what we get? We get that velocity vector is equal to this vxi plus vyj plus vzk. So this is how we get velocity vector, displacement vector from position vector in three-dimensional Cartesian coordinate system.